So today we are going to see the basic illumination model. So basic illumination model, it is a simplified method for light calculating the light intensity. So illumination means we are calculating the light intensity. Light calculations are based on then how we calculate whatever the light intensity we are going to calculate, that depends upon or based on the first optical properties of the surface, means which kind of that surface is, whether it is a glossy or shiny surface, whether it is a matte surface, whether it is a opaque surface, and whether it is a transparent surface. So this controls the amount of reflection and absorption of the incident line. So as we have seen, the glossy surface, it absorb less and reflect more, while dull surface, it absorb more and reflect less. So that depends upon the first calculation. Light calculations or lightning calculations are based on the opaque optical property. The background lighting condition means what bright that in detail we are going to see. When there is a studio, you can observe there are so many different types of lights in the background. In Blender also we have seen, if we change the light background lighting condition, uh, in Blender also we have seen two types of lights, point light and distributed light. So if we change that light source specification, then also we can change the lightning calculation, or there may be change in the lightning intensity calculation. All light sources are considered to be point source. Here we are going to consider point light specified with the coordinate position and intensity value color. Now, with this basic illumination model, what we are going to see? Ambient light. What is meant by ambient light? What is meant by diffuse reflection? Already we have seen the definition, but in detail. Diffuse reflection, how it is useful for calculation of the intensity, light intensity. Specular reflection and the fog model. Wand model, intensity attenuation, color consideration, transparency and shadows. So these topics we are going to see under the basic illumination model. So first one is the ambient light. A surface that is not exposed directly to a light. Okay, a surface that is not directly exposed to a light still will be visible if nearby objects are illuminated. Means that surface is not directly exposed to the light, but nearby some objects are there that are illuminated, that are reflect the light, and because of that light we can see that object. This is simple way to model the combination of light reflections from various surfaces to produce a uniform illumination called the ambient light or background light, that we call ambient light or background light. You can see, observe in this picture, ambient light here. Ambient light has no spatial or directional characteristics. Spatial or directional characteristics are not there. The amount of ambient light incident on each object is constant for all the surfaces and all over direction. Means the amount of light that are incident on this surface, these are constant, not change, and over all directions, means in this way. And that's why you can see these objects see similar in all the direction. These objects see same in all the direction. The amount of ambient light that is reflected by an object is constant. See, the amount of ambient light that is incident, okay, on each object is constant, and that's why amount of ambient light that is reflected. So this object also reflects some light, correct? So that light, reflected light, is also constant and independent of the object's position or orientation and depends only on the optical properties of the surface. So the amount of light that is reflected, okay, by the object is constant. Because the light is constant, light is not changing, so the incident light is constant and over all surfaces in the all direction. That's why the amount of light which is reflected is also constant, and it is independent of the object position. Where the object position is kept, it is independent on that, because this ambient light is everywhere in that particular scene. but it depends on only on the optical properties of the surface, means whether it is a glossy, whether it is a matte surface, whether it is a dull surface, or whether it is a transparent surface or opaque surface. So that only affect the reflection of the light. So the level of ambient light in a scene is a parameter used here, IA, okay, and each surface illuminated with this constant value. What is this IA? Is the incident ambient light intensity. Means suppose this is the object, okay, so this is the object on which the light is incident, so that we call IA, okay, that we call IA, that we call IA is the incident ambient light intensity. So the equation for this is I is the resulting intensity is equal to Ka multiply with Ia. So Ia is the light, incident light, ambient light intensity, and K is the object's basic intensity. Surface reflectivity means ambient reflection coefficient, means once this light is incident, this is reflected, and then only with our eye we can see that object. The light is incident on this object, and the same, some part of this light is observed, some part is reflected, and then we can see the object, and that reflection coefficient is Ka. So multiplication of these two is the resulting intensity, final intensity of that particular object in the ambient light. So that example is shown here in the ambient light, how the object will look like. So this is nothing but the multiplication of the light which is incident on that object, and what are the coefficient of reflection, ambient reflection of the light. So that one example. Now we move to the next, that is diffuse reflection. Previous we have seen the ambient reflection, that is the coefficient value Ka, which is the rate of the reflection or coefficient of the reflection. Now diffuse reflection. So this example is shown here. The diffuse reflection means the light is incident on the surface and it is reflected in all the direction. It is reflected in all the direction, that we call the diffuse reflection. So diffuse reflections are constant over each surface. These are constant over each surface in the scene. So if you see this surface, you can see this surface, any kind of surface if you see, it is constant and independent of the viewing direction, means in which direction we are going to see that object, it is independent on that viewing direction. The amount of incident light that is diffusely reflected can be set for each surface with parameter Kd. So previously we used the Ka as a parameter to indicate ambient light reflection. Now for diffusion reflection coefficient we use the parameter Kd, or we call it as a diffuse reflectivity, Kd. So Kd is the diffusion reflectivity, means once this light is incident on the surface, whatever the reflected light, its parameter is Kd, that is diffuse reflection coefficient. Now this Kd is always greater than or equal to 0 and less than or equal to 1. Then what, when it is 1 and when it is 0, what effect on the user viewer? Okay, so Kd near 1, highly reflective surface, means high reflection if K is equal to nearby 1, and when Kd is equal to 0, nearby 0, means it absorbs most of the incident light and reflect very less. So Kd nearby 1 is normally for glossy or shiny surfaces. Kd nearby 0 is normally for dull surfaces. Kd is function of surface color. Assume constant, it is diffuse reflection coefficient. If the surface is exposed only to the ambient light, Okay, the ambient light is there. We can express the intensity of diffuse reflection. Okay, ambient, we consider that there is a ambient light here, and the type of the reflection is diffuse reflection. Then how we can express the intensity of diffuse reflection at any point of the surface? I, ambient, AMB used here, diffusion. So ambient light with diffusion reflection, both are different concept. That is the light that is incident on the surface, and this is the deflection. So ambient light with diffuse reflection is Kd multiplied with Ia. So Kd is the coefficient for diffuse reflection coefficient, and Ia, what is this Ia? Is the incident ambient light intensity. Whatever the light intensity incident on that surface, that multiply with the reflection coefficient. So normally the simple equation for intensity calculation is that the light which is incident on that surface, it may be ambient light, it may be point source, it may be distributed light. So that incident ambient light intensity multiply with diffusion reflection, if it is that we use Kd. If it is a specular reflection, we are going to see in the next PPT. So if it is a diffusion reflection, the parameter is Kd. And multiplication of these two, simply we will get the intensity of diffusion reflection at any point on the surface. Only the multiplication of diffusion reflection coefficient and the light incident light intensity. So when we call it's ideal diffusion reflector or Lamberian reflector, surface from which diffuse reflections are scattered with equal intensity in all direction. If it is a equal intensity in all direction, then we call it as a ideal diffuse reflectors, irrespective of viewing direction. So for that, Lambert's cosine law is used to find out the intensity. The Lambert's cosine law, what is it? The radiant energy from any small surface area dA in any direction phi n relatively to the surface normal is proportional to cos phi n. So only remember that here the Lambert's cosine law is used, and that is proportional to cos phi n. And here we consider that the intensity of light is same over all viewing direction. Ambient light we consider here. So even though there is equal light scattering in all direction, that we know that in diffuse reflection equal light is scattered in all direction from the surface. The brightness of the surface does depend on orientation of the surface relative to the light source. So here a surface perpendicular to the direction, it is perpendicular, okay, direction of incident light, these are the incident light, and this surface is perpendicular to the incident light, is more illuminated, it reflects more light than the surface which is here oblique angle or which is slant. So that surface reflect less light, less illumination is there than this one. This surface had higher illumination than this surface. Why? Because this is the perpendicular to the incident light, while this is the oblique angle, at oblique angle to the incident light. Now that cos Lambert cosine law is used here to identify the intensity of the light. As the angle between the surface normal, so and indicate this one, as the angle between the surface, this angle theta normal, and the incoming light direction increases, less of the incident light falls on the surface. means this angle, this is the light source. Okay, so light is incident here, this is the light source, light is incident, and this is the angle of reflection. This is the way in which it is reflected. So that theta is important. So when it is less, when it is more, the less light falls on the surface. If it is increased, suppose the light source comes from here, then it increase the value of theta. If it is from here, then it decrease the value of theta. So less of the incident, if this angle is big one, okay, if this angle direction increases this angle, less of the incident light falls on the surface. We denote the angle of incident between the incoming light and direction surface. You can see here as a normal, as a theta. Surface normal, n is the surface normal, and this is the light source, okay, in which direction the incoming light is there. Thus, the amount of illumination depends upon the cos theta. If the incoming light from the source is perpendicular to the surface, incoming light is perpendicular to the surface at a particular point, then the point is fully illuminated. Then the point is fully illuminated. It's with high intensity. As the angle of illumination moves, that I told you, when it becomes greater from the normal surface, when this angle of illumination moves away from the normal surface, the brightness of the surface drops. And when it is perpendicular, exactly, the light comes in this direction and also reflect in the same direction. Then it is fully illuminated. The brightness is highest brightness. But when this angle of illumination increases, moves away from the surface normal, the brightness of the surface drops. So this L is the light source, N is the surface normal. Now, if L is the intensity of the point light source, so for this light source which use or incident on this surface, if its intensity is IL, okay, then the diffuse reflection equation for a point on the surface can be. See, in the previous we used the ambient light, so I ambient diffusion we call that result. But here IL is the intensity of the point light source. It is different. So IL diffusion, when it is a diffusion reflection, means scattered in all direction. So it is equal to KD. KD is the diffusion coefficient. Okay. Multiply with IL. IL is the light source. Intensity of this light source. Multiply with this cos theta. Multiply with this cos theta. It's a very simple equation. So the intensity calculation equation is multiplication of this KD is the coefficient, diffusion coefficient, reflection, in which way it reflects the light. IL is the light source incident on this surface, that is IL, its intensity of the light point light source, and cos theta is the angle between these two. So when it is increases, then the value is decreases, this value, or it is like this: IL diffusion KD IL N multiply with L. So N is the surface normal and L is the direction vector for the light source, unit light source direction vector. So N is the unit normal vector to the surface, or it is called surface normal, and L is the unit direction vector to point light source from a position on the surface. So that value is L, multiply with this N, multiply with coefficient, diffusion reflection coefficient, multiply with intensity of the incident light, point light source. All these together, or you can use cos theta. All these together we calculate the intensity of that particular surface with diffusion reflection, and some point source light. Example is shown here. It shows the diffusion reflection using the various values of parameter Kd. So Kd is the reflection parameter. Kd is the reflection parameter. In which way it reflects. So it is 0 to 1. So if when it is nearby 0, you can observe it reflect less, and that's why the surface intensity is less. But when it is nearby 1 or it is actually 1, then it reflect more. Then it reflect more. So in that case, you can see the intensity of the object is more. That's shown here with different values. Kd 0.04, 0.4, 0.55, 0.7, 0.85 and 1. And in every diagram you can see the intensity of the light is different. Now, we can combine the ambient and point source intensity calculation to obtain an expression for total diffuse reflection. So total diffuse reflection, we are going to find out it along with ambient light. If there is ambient light and point light source is there, both are there, ambient light is there, also point source also there, then the combining these together we can get the total diffusion reflection. So that is here. The first total diffusion IDFE is, first it is Ka into Ia, means the ambient light coefficient reflection, ambient coefficient reflection, and this is the intensity of the ambient light, plus this is the diffusion reflection coefficient. The point source is also there in that scene, so its intensity multiply with cos theta or multiply with surface normal and L light source. So all these together we can find out the total diffuse reflection. Now both Ka is, again I am repeating, Ka is the diffusion ambient reflection and Kd is diffusion reflection coefficient. Depend on surface material properties and assign the values from 0 to 1. In the previous example we have seen the Kd values, this from 0.4 to 1, how the intensity value changes, and Ka, we know that ambient reflection coefficient. So here again another example shows, suppose IAIL means intensity of the ambient light and intensity of the point source, both are used here in this scene. If intensity of ambient light and intensity of the point source both are equal to 1, means highest intensity of the light is there in the scene, and Kd means diffusion reflection is 0.4, diffusion reflection coefficient is 0.4, and there are different values of ambient coefficient reflection from 0.0 to 0.6. So when it is less, you can say here intensity is also less, and when these values increase, you can see here the intensity is also increased. So in this way, all these things are affect the total diffuse reflection or total the calculation of the intensity. So when we calculate the intensity, if it is the ambient light, then ambient light and ambient coefficient reflection is used. If we use the diffusion reflection, then in any point source, light source, then the point source intensity is important and the coefficient reflection for the diffusion is also important. Both are multiplied with the value of cos theta. What is this theta? It is the angle between the light which is incident on the surface and the reflection of that particular light. So that angle is used, or n into L method is used. And if both of these are together in the scene, ambient light is also there and light point source is also there. So in that case, both are combined together, we will get this equation. And with that equation, you can see the results in different ways. As these values are increased, any value, if we consider Ka as fixed and Kd is changes, also you can see the change in the intensity. That is diffusion reflection. Here it is shown. So you can observe the difference between these two. This scene, ambient light illumination, and this is the diffusion reflection illumination. Okay, so you can observe the difference between these two. Why? Because here is the intensity is more. Okay. Now, as we have seen with the diffusion reflection, now we are going to see it with the specular reflection. So, specular reflection means what? The light is incident on the surface, but at particular spot, the intensity of light is more than the other one. The reflection is more than the other one. So, in this example, it is shown that here at this spot, bright spot is generated. Why? Because its reflection is more than the others. So specular reflection is the result of total or near total reflection of the incident light in concentrated region. What we call it as a? We call it as a concentrated region. So at this region, more light is reflected. At this region, more light is reflected. So we call it as a concentrated region. Around the specular reflection angle. Shiny surfaces have narrow specular reflection range. So here you can observe that this shiny surface, it is a single bright spot. Why? Because it is a narrow. This one also narrow. Now when this surface becomes dull, it is a wider reflection range. When it is dull, it is wider reflection range. But when it is narrow, you can see here this part only, and sorry, when it is a more shiny, then here the narrow specular reflection range is there. And when it is a dull surface, have a wider reflection range. Now, the calculation that we are going to see. So, figure shows the specular reflection direction at a point on the illuminated surface in this figure. R represents the unit vector in the direction of specular reflection. So, R represents the unit vector in the direction of specular reflection. This one, okay? This R. L, again the same. Unit vector directed toward the point light source. So, light source L. V, unit vector pointing to the viewer from the surface position. Again, the viewer direction is also important in the specular reflection. In the diffuse reflection, irrespective of the viewer direction, from where the object that viewer is going to see, that is not important in the diffuse reflection. But in specular reflection, the viewer direction is also considered. So V is a unit vector pointing to the viewer from the surface position. Angle phi, this angle phi, okay, this one is the viewing angle relative to the specular reflection. Means reflection is done in this direction, okay, R, and this is the viewer direction, or where the viewer. So that in between the angle is phi, and the remaining angle is theta. Same, it is between the light source and surface normal, and it is between the surface normal and the reflection, that is theta. Ideal reflectors, perfect mirror, when we call incident light is reflected only in the specular reflection direction. Means if this one is 0, if this one is phi is 0, means the viewer is also in this direction. Viewer is also here. Then in that case, V is also here in the same way. 0, angle is 0. Then ideal reflection. So remember that L is the light source, V is the viewer direction, R is the reflection. Okay, specular reflection, unit vector, N is the surface normal. So what Phong model is there? So specular reflection, it is calculated using the Phong model. So Phong model is empirical model for calculating the specular reflection range. Specular reflection range, as I told that it is different depends upon the surface. When shiny surface, its range is narrow, but when it is a dull surface, it's a wider range. So that range, set the intensity of the specular reflection proportional to cos ns phi. Angle phi, what is the angle phi? It is the angle between the viewer and the reflection, V and R. Angle phi assigned values in the range 0 to 90 degree. Okay, 0, if it is a 0, then it is a perfect reflection. Ideal reflection means the viewer and the reflection is in the same direction. But if it is not 0, then the maximum value is 90. Why? Because cos phi values from 0 to 1. We know that cos phi values are 0 to 1. In the previous example also we have seen it is 0 0.4, 0 0.8, in this way 0 0.7 up to 1. So for that, the angle that we consider here, this angle phi, okay, between R and V, it is 0 to 90 degree. Specular reflection parameter, as we have seen the diffusion reflection parameter Kd, ambient light reflection parameter Ka. In this same way, specular reflection parameter Ns, it is called as Ns, is determine the type of the surface. Means which type of the surface? It is a shiny surface, dull surface, matte surface, etc. And specular reflection coefficient Ks, as we use Kd and Ka. So here another is equal to some value ranges from 0. Here we have seen the Ka ranges, Kd ranges from 0 to 1. In the here also Ka ranges from 0 to 1 in these two examples. In the same way Ks, it is the specular reflection coefficient. It is ranges from 0 to 1. Then along with this specular reflection parameter Ns is used, which determine the type of the surface. There are different types of surfaces, so that also affect shiny surface or dull surface. So two examples are shown here. Shiny surface, large Ns, and dull surface, it is small Ns. When it is a two types of surfaces in this specular reflection Ns parameter, either shiny or dull. When shiny, when this is a large Ns and dull surface small Ns. So very shiny surface is modeled with a large value of Ns 100 or more. So shiny surface Ns value is 100 or more, and dull surface has value nearby 1. For perfect reflector, Ns is infinite. The value of Ns is infinite. So in this way, shiny surface, you can see here the narrow is generated. Okay, narrow range is generated, and in the dull surface, the wider range is generated. Why? Because this Ns is more value here 100 and more, while this dull surface Ns value is nearby 1. So the another example is shown here with the Phong model. Cos Ns. So Ns, I think you understood what is Ns. That is the type of surface. So Ns 1, if it is a 10, you can see here. When it is a more, narrow range is generated, and when it is less, broad range is generated. Now, Phong specular reflection model, the calculations are shown here. The same diagram. L is the light source intensity or the unit vector, light source unit vector. N is the surface normal. R is the reflection, specular reflection, and V is the viewer direction. So Phong specular reflection model, I spec is equal to, as we use I diffuse, I ambient, in the way here I spec means specular reflection. Ks, what is this Ks? It is specular reflection coefficient. In the previous we used diffusion reflection coefficient and ambient coefficient, reflection coefficient. So in this way Ks multiply with RL if there is a point source. So this point source is there, light source is there, its intensity is IL, multiply with cos ns phi. So phi is the angle between the reflection and the viewer direction. Multiply with cos, or that cos we calculate for this phi, and s. What is this ns? It is the type of the surface. When it is a shiny, its value is 100 or more. If it is a dull, then its value is nearby 1. Or the same is written in this way. I spec is equal to Ks multiply with RL multiply with V into R. Okay. V and R are unit vectors in this, V and R. V is the viewer direction, R is the reflection. So you can use this one cos ns phi or VR and S raised to ns. Ns is the type of the surface, shiny or dull. So you can see here the example, the same diagram or the same scene you can see here. How it looks with the specular reflection. Why? Because it reflects the light at one particular surface, it reflects more light. Concentrate light is there, and that's why you can see here the shiny surface. Here you can observe the effect of the light. If we combine this both diffuse reflection and specular reflection, I is equal to I diffuse plus I specular. If there are multiple light sources, see here we consider single light source, okay? IL is the intensity of that light source. When there are multiple light source here, then you can observe here summation of I 1 to n. So n number of light sources are there. Then this equation is multiplied with the intensity of all these light sources. If there are multiple light sources, that is shown here. Then the visible line determination, visible surface dissemination with ambient. Some examples are shown here. Only ambient is there. It is diffuse reflection. Then gar shaded, that we are going to see afterwards in detail. Specular reflection. You can observe here the difference between all these one, depend upon the type of reflection. Now, wand model. So, provides method for simulating studio light effects. Now, here in this model, we are going to see the different studio light effects. See, normally when we draw the we take the picture with our mobile. So we use, as it is light available there in home or in college, when you are taking the pictures with your mobile, you are not using so many light effects. Okay, only you can change the operations in your mobile. You can change only the flash and in this thing, light, night mode, day mode, etc. But the light effects we cannot add. So in studio, what normally they perform, how the pictures are good in studio, why we went to the studio for taking the pictures, because in the studio the different light effects are used for controlling the light intensity in different direction. Light sources are modeled as point on a reflecting surface using the Phong model for surface points. Phong model already we have seen. Specular reflection. Then the intensity in different direction is controlled by selecting values for Phong exponent. In addition, light controls such as barn doors, that I will show you with diagram what is barn doors. Barn doors, some students may know it. Barn doors are used there. Spotlights are also used there. Used by studio photographers and can be simulated in the one model. Flaps are used to control the amount of light emitted by a source in various directions. Flaps are used there. Two flaps are provided for each of x and x, y, z direction. Spotlights are also provided in the studio. So spotlights are used to control the amount of light emitted within a cone with apex at point source. So you can see spotlights are like a cone like structure is there to control the amount of light. If we use the entire what we say our room light, then the light effect is different in our picture. But if we use such kind of lights, for example, see here, this is the barn doors that was used, this is the spotlights, and these are the reflective umbrellas, or we can say the umbrellas you can see in the studio that are used there. So for all these are for light controls. For which purpose? For light controls. You can observe in this picture, the cones are used here so that the light is controlled with this cone, with this cone. You can observe the difference. This image, and this image. There is so much difference. These are the studio effects. Here also you can observe. Changing the light effects, how the picture is changes. That is about the only one model.